Hello everyone. In this video, we are going to solve a single loop circuit using Kirchhoff's laws. So in this problem, we are to find the current inside this single loop circuit. So first, we determine the direction of current. So we don't actually know the direction of the actual current since this battery provides current in the clockwise direction, and we have here another battery that wants to drive a current in this direction. So it's not actually straightforward given in this problem what is the direction of current. So hence we will take a guess on the direction of the current first, and if we solve a value of positive I, we are correct in the direction, and if we solve a value for negative I or negative current, our initial guess is opposite of the that direction. So we will be solving it with, say this direction. So we will first assume that the current in this single loop is flowing in this clockwise direction. So we will call that current I. Okay, so this current I will cause a polarity on this resistor. For this first 8 ohm resistor, it will cause a polarity of high to low. So if we assume that the current flows in this direction, of course this resistor must give a voltage drop due to this. This resistor will experience a voltage drop due to the direction of the current. And also this 10 ohm resistor will experience a voltage drop. So this has plus to minus, this is plus to minus. Okay, so now that we know how our resistors are, let's write it down. On resistors. So now that we know how the polarities of resistors with respect to our guessed current, we will now assign a loop current. So in this scenario, we are going to assign a loop current that coincides with the direction of our guess current. Okay, so let's assign this loop current A to be in the same direction of I. So this is just a arbitrary choice of whether we are to follow the direction of our current I or not. So in loop A, if we are to use Kirchhoff's loop rule, we know that starting from here, let's start from here. So we encounter a region of low to high potential. So we assign this as a potential voltage gain. So this will be a gain of 6 volts. So we are now traversing loop current A. So next, we encounter a resistor here, and upon loop current A passing through this 8 ohm resistor, it encounters a region of high potential to a low potential. So this means voltage is dropped. So this becomes minus current passing through this resistor, in this case, this is I, times the resistance of that resistor, which is 8 ohms. And then next, we encounter this battery, and we know that batteries actually raise the potential energies of positive charges, but in this case, the direction of the loop current is such that it moves in the region of the battery wherein it starts from a high potential plus and then ends up with a low potential minus. So in the perspective of loop current A, it experiences a voltage drop. So we write this in the loop rule as minus 12 volts. So why minus 12 volts? Because loop current A is in this direction and it first encounters high to low. That's why we have minus 12 volts or voltage drop. And then next, finally, we encounter this 10 ohm resistor, and we know that it starts from high to low, and this should also be a voltage drop. So this will be I times the resistance of that resistor, 10 ohms. And once that we close our loop here, we have accounted to their sums, and it must be equal to 0. So by writing Kirchhoff's loop rule, we can now solve for the current inside the circuit, which is I. So solving for I, we have 6 volts minus 12 volts equals, I'll move I to the right hand side. We have 8 ohms plus 10 ohms. So I equals 6 volts minus 12 volts over 8 ohms plus 10 ohms. This will be equal to 6 minus 12 minus 6 over 18. So 6 over 18 is 1/3, and we have negative. So this will be minus 0.33 amperes. So now that we know the value of the current, let's determine its direction. Since we got a negative value, minus 0.33 amperes, this only means that our initial guess of current is on the opposite direction. So we initially guessed a current that is driving in this direction, and since we got a negative value, the physical current that is flowing in this circuit is in the opposite direction. So this is the correct direction of the current.